All right, so the objective today is solving linear equations at 80% accuracy or higher. So can you create an equation that represents whatever problem we're working with? And can you correctly identify inverse operations? And can you solve for a variable? If you are ever absent, make sure that you are keeping up with the class by clicking on the daily slideshow. So I make one literally for every single day. And it has any video lessons, which I am recording now, and it will be uploaded before school ends in there. And also any assignment instructions. So the way that this works, now that we are starting topic 1 today, is that these lessons take 2 days. So there's 4 parts. Day 1 is going to be the explore piece, which we'll talk about in a second, and the understanding and applying piece. The next day is your independent practice. So we built in a chunk of time in class for you guys to work on your assignments, and then that small quiz at the end. All right, so that's how the days work. So since we're starting lesson 1-1 today, you are a day behind. So instead of having the quiz today, it's actually going to be tomorrow. All right. Any questions there? Okay. So those are the deadlines I just talked about. We're planning for 2 quizzes this week, but we'll just have to see how far we get. So the assignment isn't assigned today. It will be tomorrow, and I'll give you class time for it. The only way it becomes homework is if you don't finish it. Yes?
Tomorrow's Thursday, why does it say August 13th? Friday.
August 13th is Friday. And then you can just throw it in. Thank you. All right, and then tomorrow is, well, actually, you should say tomorrow the 12th. Right? So that's where the mistake is. Friday the 13th is correct. All right. Any questions? All right, the quiz was supposed to be today, but it's not. So it's now Thursday. Tomorrow. All right, now we are going to do the explore piece. So let me project it. The explore piece is what you need your workbook for. All right, so you all got a workbook. So open it up to one of the first few pages. It looks like this. It says 1-1. And once we get the hang of this more, those are going to be more of our like bell work. So it's stuff that you answer and then discuss in your table rows or the table next. Since this is our first one, we'll kind of discuss it together. And these are always going to be connecting to prior learning, while also connecting to what you're about to learn. So we have, well, first, any volunteers to read it? Anyone? Or read this first problem that's in your book. You want to read it?
Do you want me to read that? Or start off with Joshua?
Yep, Joshua right here, just this first.
Joshua is going kayaking with a group during one of his vacation days. His vacation planning is $50 for a kayak rental.
Good. Anyone want to read this first part, part A? Okay, well, actually, we'll let our friend back there.
How can Joshua determine the number of hours he can run a kayak for himself? Describe 2 different options.
All right, now before you all jump in and answer that question, we all need to give everyone time to think about it. So we have someone who has set aside $50 for a kayak rental, and here are his options. Right, he could do a single kayak for $15 an hour, single seat kayak for $18 an hour, or a double kayak for $25 an hour. So let's look at one of the options. The question says, how can he determine the number of hours he can rent a kayak for himself? So let's look at the single kayaks first. Sorry, this thing's always takes a minute. Here we go. All right, so let's talk about the single kayak first. If that is $15 an hour and he has $50, can you rent it for 1 hour? Can you rent it for 2 hours? How much would it cost for 2 hours? $30. So he does have enough if he has 50. What about 3 hours? How much would that be? And then 4 hours? No, because now that exceeds his budget. So what operation were you doing when you were figuring out how much it costs per hour? So each time you added 15, what's repeated addition?
Multiplication.
Multiplication. So if I wanted to make some sort of expression or equation to figure out how many hours he can rent it for, I could do it like this. I could say 15x, where x is the number of hours, and then I can even do equal to 50 and solve for x, right? So you guys kind of did it maybe without thinking about it, but that's how you figure it out. So if he wants to do the single kayak, and you can write this down, he can rent it for, oops, I put that at least. He can rent it for either 1 to 3 hours. That's how much he can afford. So this side of the room, so we'll kind of split it this way if you're in the middle, like right down the middle. This side of the room, figure out how many hours he could rent the second option for on your paper. So don't say it out loud. Figure out the maximum number for that option. And then this side of the room, figure out the maximum number for the third option. All right, in your workbook. Oh, you need one. Anyone need more time? All right, so the single seat kayak. If he wanted to rent that one, over here, what's the maximum number of hours that he can rent it for? Anyone? 2 hours. And how much is it at 2 hours? $36. What would it be if it was 3 hours? 54, which is too much, right? He only has 50. So 1 to 2 hours he could rent the single seat kayak for. Over here, the double kayak, how much? What's the maximum amount of hours he can rent it for? 2. So he could rent it for 1 to 2 hours again. So which one would you say is the best buy? All right, the first one. And that seems to work because it says for himself. It doesn't say he needs another person in there. So the single one works just fine. All right, now the goal today is to solve linear equations. And maybe you realized it, maybe not. But linear equations always follow this format if you want to write it down. So somewhere, maybe off in the margins. Y equals mx plus b. Does that sound familiar? All right, that's what a linear equation is. So this these rates that we have here, if we wrote them down as 15x, 18x, or 25x, those are all linear because they're going up or down at a constant rate. And because it's being multiplied by an unknown. Okay, so what does the m represent in the y equals mx plus b? Can you remember? Yes? No, close. The slope. All right, the y-intercept is something else in here. The m is your slope. So if I were to graph all of these, the slopes would be how much it costs per hour. Okay, questions there? All right, so let's look at part B. So it says, Joshua found that there is a $25 non-refundable equipment fee in addition to the hourly rates. How does this requirement change the mathematics? Now, before you answer, let's let everyone think about it. All right, if we add a $25 non-refundable fee, how does that change the situation and the math of the situation? So how would the equation differ now? Yes?
You would technically be getting ripped off if you have to pay another $25 fee because it's only $15 per hour for a kayak.
True, but that is something that they do charge, right? They actually do include like a normal, here's just to rent it, and then here's per hour. But how can I like write that in math, numbers, and symbols? So if I was doing the single kayak, which was $15 an hour, so 15x, how would I put in that non-refundable fee? Yes? Plus 25. Right, because he has to pay that no matter what. And then the hourly rate. So add them together, that gives you your total costs. So this is still linear, right? Is it not? Does it look like y equals mx plus b? Yes, it does. Is something increasing or decreasing at a constant rate plus a non-refundable fee? So what would that 25 be if I were to graph it? Yes, the y-intercept. So remember the b is for your y-intercept. That's going to be your starting fee or whatever the different situations where you're starting at. Questions there? All right, so that kind of introduces us to those linear equations. We'll do more with them as we go. I'm going to erase this. Anyone need it still there? Okay. Then scrolling down, I think there's one more part. So on your paper, talk about how it's different, how those two equations were different and how they are the same. All right, so just in words, write a sentence. What's the difference from part A having 15x versus part B having 15x plus 25? Think about it like how it looks and also how it changes the situation. Does it mean that he can rent any kayak he wants now? Right, at least not as long. So write a sentence or two in your workbook. How is it the same? How is it different? So first, you need to understand the steps for solving multi-step equations. So we did two-step equations yesterday, actually. So multi-step equations just means more than two. But either way, still follow the same process, still work to isolate whatever variable, just think of it as order of operations that working backwards. All right. These are the papers we picked up from the back table, FYI. So number one, or step one, is to distribute if necessary. Distribute if necessary. All right, so if you see numbers in the format that we need to distribute, so I'll write it up here. If you need to know, and I'll write it with letters just because it can be really any number. All right, if you see numbers in this type of format, that means you need to take the outside number and multiply it by both of the inside numbers. And you can only do that if there's parentheses. And if in between those numbers and the parentheses, there's a plus or a minus sign. Right. So multiplying it by both the numbers inside is the first step. Distribute if necessary. Step two is to combine like terms. And we'll talk about what like terms are in a second. A lot of you already know. All right, but after distributing, combine like terms. Lastly, you are going to solve for the variable. So solve using inverse operations, which is what we talked about yesterday, inverse operations. Those undo what's being done. So step 3, solve using inverse operations. Now, some vocab that we need to go over before we just jump right into it, because I use these words a lot. And if you don't know what they mean, it does make it a little hard. So you might have heard them before, or maybe just forgot. But what is a coefficient? Coefficient. Usually it helps if I have an example, so let me write an example up here. All right. What number in there would be a coefficient? Yes? Okay. The number with the variable. So coefficients are numbers in front of the variable. So like 3 in this example. Any number that you have in front of a variable is called your coefficient. Anyone know what these single numbers are called? They're called constants. All right. Just FYI, I know I don't have that word in here. But single numbers are your constants. Numbers in front of variables are your coefficients. Coefficient. All right. Now we said it's in front of a variable. So what is a variable? Yes. You. The x, right? So it's your unknown. So your variable is going to be your unknown, which is represented by a letter. All right, usually that letter is X or Y, those are really common, but really it can be any letter. So variables are unknowns represented by a letter. All right. Now let's talk about what like terms are. So let me add a vocab word if you can fit this into the bottom of your list. Sorry, there may or may not be a lot of room. But first, let's talk about what terms are. So in this example that I have up here, the 3x minus 7, how many terms do I have? I don't have one term. I have, yes,
Two.
That's two terms. All right. So terms are like units of numbers, and they're separated by plus, minus, or equal signs. So if you want to know like terms, how to figure out what a term is, they're going to be separated by plus or minus signs. Also equal signs, but plus or minus signs. All right, so when I say combine like terms, I'm talking about numbers that kind of look the same. All right, so I don't have any like terms in this example, but let's say I did this. Let's say I added something onto here, like 2x. What are my like terms in there? Yes? The 2x and 3x. So your like terms are going to be numbers. So numbers that have the same variable. Numbers that have the same variable. Also, like it's the same variable to the same exponents is the definition. But for right now, you can just think of it as numbers that have the same variable. So if I said combine like terms, we're combining the coefficients only. So if I said what's 2x plus 3x, what would you tell me? 5x. So notice that the variable doesn't change, it doesn't become like x squared or something. You just combine the coefficients, so the numbers in front. Does that make sense? All right, one more definition for you. Solution of an equation is going to be the value of x or whatever, value of the variable. I'll just put value of x. That makes equation true. Solution of an equation is value of x. That makes equation true. The value of x that makes the equation true. So once we get x equals whatever, that's my solution. Should be what makes the equation true. Questions? All right, so finish writing that definition and then we'll jump into some examples. And the way that this is set up, because you have a workbook, is that these papers that I provide you are kind of like the teacher notes or like the teacher examples. So I'll show you one and then you'll try one, but the try-its are in your workbooks. All right. So first, this one is on this paper. All right, solving linear equations. What's the value of x in this equation? All right, notice we do have more than 2 steps here, but it's the same structure as what we did yesterday. We're still doing order of operations backwards, or in other words, getting rid of what's farthest from the x. Now, I know we can distribute here. All right, you can distribute that too, but you don't really need to in this one. All right, you can, it won't change your answer, but we're doing order of operations in reverse for this one. So what is farthest from the x that I can get rid of? The 8, right? Everything else is in the same fraction of it as it. The 8 is farther away. So what's opposite of subtracting 8? Adding 8. And then what you do on one side of the equal sign, you do to the other side. So on the left side, what do I end up with? Good. So same thing I had before, except now we don't have the 8s there because they cancel. On the right side, combine like terms. So those are both constants. You can combine them. What's 32 plus 8? 40. Good there. Now what is farthest from the x? The 3, right? Because the 2 is in the same line, the 3 is farther away. So what's opposite of dividing by 3? Good. So do that on the left side to make the 3's cancel. Do it on the right side, because whatever you do to one side, you do to the other side. On the left side, what do I end up with? Good. 2 times the sum of x and 4. Good. And 40 times 3 is 120. Now what's farther from the x? The 2. Good. Because the 4 is in the parentheses with the x, the 2 is still farther away. So opposite of, well, first let me ask you, what operation is going on right here? So opposite of that is, so do that on each side. Left side, they cancel out. So on the left side, since all we have is this set of parentheses, the parentheses can go away now. And what's 120 divided by 2? 60. Good. Almost done. Just one more thing to do to get the x by itself, which is to do what? Subtract 4. And sorry, I'm a little out of room. Now, yes, subtract 4 from each side. On the left side, we have x. On the right side, we have 56. Question? Like in the beginning, or like from here? Yes. All right. It is kind of an extra step, which is why I didn't do it in this one, but you should still get the same answer. All right, good question. Any other questions? All right, so now you guys are going to try it, and this one's not on the paper I gave you, it's in your workbook. All right, so in your workbook, turn to this one. Looks similar, but it says 4 plus 3x minus 1 over 2. And don't be discouraged if your answer isn't a whole number, maybe it's a fraction or a decimal. If you're doing the steps and you're sure that you're doing the steps correctly, it is all right to get fractions sometimes. So try it out in your workbook and ask some questions if you have. It should be right after these. All right, so let's start going over it and see if we got the right answer or not. So let me just write it down real quick. Now, what's the first step? What number do I get rid of first? The 4, because it's farthest from the thing we're trying to isolate. So how do I make that 4 go away? Good. All right, if you thought add, just kind of correct it, think about what you can do to make it be 0. If I add 4 to 4, I get 8, I do not get 0. So 4 minus 4. That cancels out on the left side. So we just have 3x minus 1 over 2, and then 9 minus 4, which is 5. All right, good there so far. Now what number do we get rid of? And we get rid of it by, good, do that on each side. On the left side, they should cancel, right? So it's cross simplifying, makes them cancel out. So on the left side, we just have 3x minus 1. On the right side, what's 5 times 2? Good. All right, now what do I do to get the x by itself? All right, add 1 to each side. All right, sometimes people wonder why this time we're adding. All right, right now the 1 is negative, so make it cancel out. On the left, we have 3x. On the right, we have 11. Now, what do we do? Good, because right now it's being multiplied, so opposite is dividing. And we get x equals 11/3. It is all right to leave your answer as the fraction form. If you made it a decimal, then it should have been about 3.7 or 3.67. I'll accept either answer. Usually I prefer the fractions because they're more exact, whereas the decimal you have to round. All right, any questions? Yes. 3 2/3. So that's 9, 10, 11. That works too. All right, so if you made it a proper fraction, a mixed number, that works as well. All right, questions? All right, good job there. Now something slightly different. So we're going to look at consecutive integers next. Any questions before we move on? All right, so consecutive integer problems. We have the sum of 3 consecutive integers is 132. What are those 3 integers? A couple things you need to know to be able to solve this. What does consecutive mean? Or can you give me an example of some consecutive numbers? Okay, I'll give you an example. 1, 2, 3, 4. All right, those are consecutive numbers. 5, 6, 7, 8. 27, 28, 29. Right? So consecutive integers are numbers that are right next to each other. So numbers right next to each other or going up by 1. Each time. So numbers going up by 1 each time are what consecutive integers are. So if we're trying to figure out, what are 3 numbers that are right next to each other that add up to 132? I see a lot of students try and guess. All right, that usually takes them a while and they're not always right. So it's not an effective method. But we can write this out. So you can kind of use this setup for all consecutive integer problems. So if I say that my first number is n, for example. So n can be my first number. What's my second number going to be in like math symbol? If it goes up by 1, I'll go down by 1. If it goes up by 1, my second number would be, well, we don't know what the first number is. So the first number is n, that's our unknown. Our second number would be, come on, I know you guys are like almost there. N plus 1, right? If they go up by 1 each time, and my first number is n, my second number is n plus 1. All right, and this one's asking for 3 consecutive integers, so we need a third. What would be my third number? N plus 2. Are we seeing the pattern? If it asks for 5 consecutive integers, we would do the same thing until we get to 5 numbers. All right, but that makes sense, because what if it was 1, 2, 3? Right? Isn't 3 1 plus 2? So that's we can use as a structure for all of these types of problems. All right, now read the problem again to figure out like what your equation is going to be. The sum of 3 consecutive integers. So what does sum tell you to do? Add. So that means I'm going to add these together. So I have n plus 1 plus n plus 2. All right, that's the sum of the 3 integers. Is what is in symbols? Equals. So is equals 132. All right, that's how you set up those types of problems. So follow your steps. Before we start doing inverse operations to solve for n, we need to combine like terms, right? I did hear someone say. So what are my like terms in this one? Ethan, sit up. What are my like terms? All right, I have multiple n's. If there's no coefficient, what's the coefficient assumed to be? 1. So I have 1n plus 1n plus 1n, which equals 3n. Good. Are there any other like terms? 1 and 2, which combine to give me, and since it's positive, I'll put plus 3. All right, so we combine like terms, bring down that equals 132. And now this is something like what we have solved, right? So get the n by itself. So what do I get rid of first? The plus 3, right? The opposite is good. Sorry, I kind of wrote on that. We get 3n equals, what's 132 minus 3? 129. And then what's opposite of multiplying by 3? So divide by 3 next. And you can use a calculator for that. You just can't use the calculator on your phone. You can either use a handheld calculator, you could use like on your Chromebook, you have decimals there. That's fine. All right, but I see someone doing it on their calculator already. So tell me what you get. 43. All right, that sounds like what we got first hour. Now, is that the whole answer to the question? It says, what are the 3 integers? So if n is 43, so that's my first number, what are the other 2 numbers? So my answer is going to be 43, 44, and 45. Right? Because n is 43 plus 1, 44 plus 2, 45. Make sense? All right, I'm gonna have you guys try the last one in your workbook, but pay attention to this part. So on your try it says 3 consecutive odd integers. So what does that mean, or what's an example of that? Consecutive odd integers, yes? Megan? 1, 3, and 5, right? What's another one? Example? Okay, 1, 3, 5, 5, 7, 9, 11, 13, 15. So instead of going up by 1 each time, it's going up by, not by 5, it's going up by 2. Same with like consecutive even integers. It's going up by 2 each time if it says even integers also. So I'll kind of help you set this up. My first term can be n or x, n. My second term would be what? Not plus 1, plus 2, good. And my third term would be n plus 4. So it goes up by 2 each time. Make sense? So try that out. I kind of helped you set it up. You need the sum of 3 consecutive odd integers that equal 57. All right, try that for the last few minutes and do not pack up until 9:19. If you pack up before that, I'm gonna yell at you. All right, work on that problem till 9:19. And we'll review the answer tomorrow morning.